Why does time only move forward? It's a question that has puzzled the greatest minds in physics and philosophy for decades. Today I'm diving into the intriguing concept of the arrow of time. This concept, first brought into the limelight by Sir Arthur Eddington in 1927, challenges our understanding of time itself. At its core, the arrow of time refers to the one-way direction of time. Think about it. Everything from aging to the cooling of coffee happens in one direction forward. But why is this the case? Let's start with T-symmetry. In a perfect world where time is symmetrical, a film of a vase shattering on the floor would look realistic, whether played forward or backward. However, in our world, we know that's not possible. The vase shatters and it stays shattered. This is where entropy comes into play. Entropy, part of the second law of thermodynamics, tells us that things tend to move from an ordered state to a disordered state. This increase in disorder, or entropy, is a fundamental reason why we perceive time as moving forward. It's irreversible, but there's more to it. Physicist Sean M. Carroll points out that just as the distinction between up and down breaks the symmetry of space due to Earth's gravity, the distinction between forward and backward in time near the Big Bang breaks the symmetry of time. So in essence, all arrows of time, be it the growth of children or the fading of stars, are tied to our universe's conditions since the Big Bang. We're caught in an unending forward march because of the cosmic environment that surrounds us. Fascinating, isn't it? The arrow of time isn't just about physics, it's about the fundamental fabric of our existence. Could we ever see it reverse? Now that we've grasped the fundamental concept of the arrow of time, let's dive into some proposed solutions to the arrow of time paradox. This paradox highlights the contrast between the reversible nature of microphysical laws and the irreversible macroscopic phenomena we observe in our daily lives. One fascinating theory comes from physicist Lorenzo Maccone. He suggests that entropy can actually decrease, but any process where entropy decreases would erase all evidence of its occurrence, including any memory an observer might have of it. This aligns with the second law of thermodynamics, as physics cannot study processes where entropy has decreased due to a complete absence of information. Maccone's solution is intriguing as it relies on the assumption that quantum mechanics is valid at all scales. He presents thought experiments where entropy decreases and all records of it are permanently erased, suggesting that time-reversible phenomena could exist but not be observable. Let's not forget Zeno's paradoxes. While not directly addressing the arrow of time, these paradoxes challenge the coherence of motion and time, suggesting they lead to logical contradictions. Modern solutions leveraging calculus have provided insights into the complexities of infinity and continuous motion, which can relate to the arrow of time paradox. And then there's the concept of multiple timelines. In the context of time travel, one solution to the paradoxes of time is the creation of new timelines. When a time traveler goes back in time, their actions in the new timeline do not affect the original timeline, thus preserving the unidirectional flow of time in each separate timeline. These theories and solutions remind us that while the arrow of time is a fundamental aspect of our universe, it's also a rich field of ongoing research and debate. So what do you think? Which of these solutions resonates with you the most, or do you have another theory in mind? As we continue our journey through the mysteries of time, let's explore some other fascinating paradoxes that challenge our understanding of this elusive dimension. First up, when a time traveler's actions in the past become part of history and may ultimately cause the events they are trying to prevent. Imagine trying to stop a disaster only to realize your actions are what set it in motion in the first place. This creates a temporal causality loop where past and future events influence each other in a circular sequence. Next, we have the ontological paradox. It involves an item or information that is sent back in time and becomes the cause of itself existing in the first place, with no clear origin. For instance, a time traveler might bring back a famous book from the future, publish it in the past, and grow up to be the person who originally wrote it. But where did the book really come from? This is where a person travels back in time and kills their grandfather before their parent is conceived, preventing their own existence. This creates a logical contradiction. If you never existed, how could you have traveled back in time to commit the act? If a being can perfectly predict your future actions, does that negate your free will to choose otherwise? This paradox raises deep questions about determinism and the nature of choice. The stemming from Einstein's theory of relativity involves twins where one travels at high speed in space and returns younger than the twin who stayed on Earth. This phenomenon, due to time dilation, shows how time can flow differently under varying conditions of speed and gravity. Finally, while not directly a time paradox, it deals with the probability of extraterrestrial life and why we haven't encountered it yet, considering the vastness of time and space. With billions of stars and potentially habitable planets, why is there such a deafening silence from the cosmos? These paradoxes not only boggle the mind, but also push the boundaries of our understanding of time and its mysteries. They remind us that time is not just a straightforward progression, but a complex and often perplexing tapestry. What are your thoughts on these paradoxes? Do they challenge your perception of time? Share your insights in the comments below. The many worlds interpretation posits that every possible outcome of a quantum event actually occurs, but in distinct, non-interacting branches of the universe. Imagine an ever-branching tree, with each branch representing a different outcome. Now let's see how this idea addresses some classic time paradoxes. First, the grandfather paradox. In the MWI framework, if a time traveler were to go back and prevent their grandparents from meeting, it wouldn't erase the traveler's existence. Instead, it would create a new branch of the universe where the traveler was never born. The original branch, where the traveler did exist, continues unaffected. Next, the Bootstrap Paradox. This paradox involves an item or piece of information that appears to have no origin. MWI explains this by suggesting that the item exists in a separate branch where it was originally created. When it's brought back to the past in a new branch, it seems to have no origin, but in reality it simply belongs to a different quantum branch. Then we have the Predestination Paradox. MWI elegantly sidesteps this paradox by proposing that any actions taken by a time traveler in the past lead to the creation of a new branch of the universe. This new branch contains the events influenced by the traveler's actions, while the original timeline remains unchanged. Thus, events that seem predestined are just occurrences in a branch where the traveler's actions have already been accounted for. So, how does the many worlds interpretation change our perception of time and its paradoxes? It suggests that time is not a single linear path, but a complex web of branching possibilities. Each choice, each action creates a new branch, a new reality. This perspective not only resolves many paradoxes, but also expands our understanding of the universe's infinite possibilities. What do you think about the many worlds interpretation? Does it make the concept of time travel more plausible? Or does it raise even more questions? Share your thoughts in the comments below. Thank you for joining us on this mind-bending journey.